Okay, today's lesson is 1.5, the distributive property. And compared to yesterday, this is going to be pretty short and pretty simple because we only have one property that we need to discuss in this particular section. So if we have A times B plus C, that is the same thing as A times B plus A times C. Okay? And if there would be a subtraction sign in the middle, A times B minus C, that would be AB minus AC. Okay? So the sign in the middle of B and C inside the parentheses is important. Okay, so let's see some examples here with actual numbers in them. Let's take a look at this example. If we have 8 times 10 plus 4, that's the same thing as 8 times 10 plus 8 times 4. Okay? 8 times 10 is 80, and 8 times 4 is 32, and so 80 plus 32 is 112. And you might be saying to yourself, well, why would I want to do that? Why would I want to, why would I not just want to go ahead and add 10 plus 4 and make it 14 and then do 8 times 14 instead of having to do two different numbers? And the reason for that is that sometimes it's easier to use the distributive property and to break a number down into two different numbers, because you can then do it mentally in your head without needing to use pencil and paper or a calculator. So an example of that, let's go to the next screen, would be something like 15 times 99. Okay, now I don't know about you, but there's no way that I could do 15 times 99 in my head. And if I didn't want to have to go get a piece of paper and a pen, or if I didn't want to have to go get a calculator, there's actually a really easy way that I could do this. I could change 99 into 100 minus 1. Okay? And that, both of those multiplication problems are much easier to do in your head. So if I took 15 times 100, I would get 1,500. And then 15 times 1, I would get 15. Okay, so I can probably do 1,500 minus 15 in my head, and that would be 1,485. Okay, so that's why we would use the distributive property when we have numbers instead of just going ahead and doing it the normal way. It's because we're trying to break the number down into two numbers, into two multiplication problems that are easier to do mentally. Okay, so here's another example. Let's do 402 times 12. So let's think about this. How could we use the distributive property to make this multiplication easier to do? Okay, and maybe you're saying I could break the 12 up into 10 and 2. That would work. I could also break the 400 up into 400 plus 2. So both of those are options. So let's go with the second one. Let's try breaking 400 up into 400 plus 2. Okay, when we do that, what we can do then is say, okay, 12 times 400. I can do that in my head because 4 times 12 is 48. So that would be 4,800. And then I can do 2 times 12 in my head. That would be 24. And then I can pretty easily add those two numbers in my head and get 4,824. Okay? So once you start to think this way, it really helps out. It really helps you to be able to do a lot of things in your head that you couldn't do before. Okay, I can just as easily do the distributive property with algebraic expressions that also have variables, as I can with numerical expressions. So an example of that would be if I wanted to use the distributive property to rewrite 5 times g minus 9, I would simply say, okay, 5 times g is 5g. I have a minus sign in the middle. So I put a minus sign there, and then 5 times 9 is 45. So that's just another way of writing the same expression. And don't be confused if the parentheses come first and the number comes after that. So let's look at another one. If I had x squared plus x minus 1, and then I had a number behind it, it wouldn't change the way that I do it. I still take the number that's outside of the parentheses and I multiply it by each number that's inside the parentheses. So 3 times x squared would be 3x squared. 3 times x would be 3x. I have a minus sign right here, so I'm going to put a minus sign next, and then 3 times 1 is 3. So wherever the number is, whether it comes before or after the parentheses, what you're doing is the same. You're multiplying every single term inside the parentheses by the number or the variable, whatever it may be, on the outside. And of course, if we had any like terms, we would combine them at the end to simplify it as much as possible. In this case, we don't have any like terms because this x is to the power of 2 and this x is to the power of 1. So those are not like terms and they can't be combined. But if there were any, we would combine them. That's the end of today's lesson, short and sweet, so we'll practice this in class.